Hello everyone, my name is Naveen Kumar. Today my topic is about high-speed aerodynamics. In that high-speed aerodynamics, my topic is about significance of area velocity relationship. Here, the area velocity relation for for the nozzle for a one-dimensional flow. Let us consider one-dimensional flow, allowing the steam tube and area A with vary with distance x, as shown in figure. Here, the the A is the area, like P is the pressure, and T rho is the density. Uh, T is the temperature, and V is the velocity. Here, A1, P1, rho 1, T1 are the inlets, and A2, V2, and rho 2, P2, and temperatures like area, density, pressure, temperature, velocity, the variations. Quasi means a small change, and let us assume all properties of a uniform flow across any given cross-section of the stream tube. And hence there are functions of x on steady flow, as we have seen, like A is equals to ax and rho is equals to rho x. Such a flow where A is equals to ax and P is equals to P of x, rho is equals to rho of x, and V is equals to V of x for a steady flow is defined as a quasi one-dimensional flow. Here, for any stream tube of area A, the continuity equation is given by, like, the continuity equation, as we all know that rho AV is equals to constant. Here rho means density and A means area, as well as V means velocity. And if you differentiate differentiation of continuity equation, here we get like density with differentiation with respect to V, like d rho a v with respect to dv is equals to rho v a with respect to like it will becomes as rho v if we taking common rho a with respect to a and with respect to v, and we get that differentiation of constant will become zero, and and here the equation becomes like a into d rho v by dv is equals to, if we take a as a common, like rho a into dv by dv plus v into dou rho by dou v, d rho by dv, and the equation becomes a d rho v by dv, and a into again we have taking the common of v, so again we taking common v with respect to this equation, a into rho plus v into d rho by dp, and dp by dv equation becomes. And as we all know that Bernoulli's equation, which is v square by 2g plus dp by d rho, integral of dp by d rho becomes constant. This comes from Eulerian equations. Differentiation and arrangement of rearrangement of with we get as vdv plus dp by rho is equals to 0. dp by dv is equals to minus rho v, and from the Laplace equation, we know that a square is equals to dp by d rho, and it becomes a is equals to under root of dp by d rho, and uh, if by substituting these forms equation, like equation 4, equation 6, equation 7 in the first form of equation, which is of a into d rho by dv plus a into rho plus v into by a square by minus dv. Here in the place of dp by d rho, we are uh, uh, we are substituting the equation of a square with here there will be a d rho by dp, so here we got that 1 by a square. And equation again while deriving, here the equation becomes a into d rho v by dv is equals to a into rho of 1 minus v square by a square. Here we are taking a rho as a common, so the equation becomes a rho into 1 minus v square by a square. And here we have a into d rho v by dv and a rho of a into rho of 1 minus m square. Here the m square means Mach number. We all know that Mach number definition is like velocity of an object to the velocity of a sound. So the Mach number here in terms of the equation is deriving in terms of Mach number, and we are getting Mach number. And by substituting equation 18 equation 2 as that, we get rho into dA by V plus uh, A into d rho into 1 minus m 1 minus m square is equals to 2. dA by dV is equals to A by V, A by V and 1 minus m square. And this is the area velocity relationship. The following information is derived from the area velocity relation. For the incompressible flow limit for Mach number is equals to Mach number is equal to 0, shows that AB is equals to constant, and this continuity for the incompressible flow. This continuity equation is valid for the incompressible flow because the density in the compressible flow, the density remains constant. So the continuity equation becomes AB is equals to constant. And if the Mach number is lies between 0 to 1, and a decrease in area results in increasing of velocity vice versa, and therefore the velocity increase in converging duct and decreasing in the diverging duct. This result for a compressible subsonic flows is same as that incompressible flows. For a Mach number is greater than 1, increasing of area results in increasing of velocity, vice versa. It shows that the velocity increasing in a diverging duct and the decreasing in a converging duct. This is directly opposite to the behavior of a subsonic flow in the divergent and convergent ducts. And m is equals to 1, dA by dA is equals to 0. It implies that there will be a location where the Mach number becomes unity and the area of passage is either minimum or maximum. And here we can see the clear polarity of this, clear significance of a Mach number and area, like area and velocity relationship. If and we know that Mach number is directly proportional to the velocity so have taken the Mach number and or relation. Further significance, if the velocity increases in a subsonic flow, if the as we know that subsonic flow is less than Mach number is less than 1, if there is a convergent section, if convergent section means there will be a decrease in area. So as the decreasing area results in increasing of velocity in the subsonic regions. Whereas coming to the supersonic, there will be a Mach number is greater than 1 or 1.2. So there will be a divergent section. So if there is a divergent section, yeah, there there is an increase in area. So there increase in area which is results in increasing area. So here from the relation of dV by A is equals to under root of dV by V m square minus 1 minus m square. That relation significance shows that if the if there is a supersonic flow, if the area is get increased, the velocity also increase. If there is a subsonic flow, the area get decreased, the velocity get increased. It is quite opposite to the subsonic and supersonic. This area velocity relation shows the velocity significance. And the decreases, if the velocity decreases, if the velocity, whenever the velocity decreases in the subsonic flow, because if there is an increasing of area, then there will be a decreasing area in the subsonic regions, where in a supersonic regions, if the area get decreased, the velocity also get decreased. A is directly proportional to V, whereas A is inversely proportional to V in this subsonic, in this subsonic. And thank you. And this is the like a ratio plot of Mach number and area. This is A star is the critical Mach number, and here if the Mach number area ratio, and with respect to Mach number relation. And thank you.